So let's discuss the graphs of zero order reaction. The first graph of zero order reaction is this. So let's discuss it. As I'm writing equation here, and we will be writing according to through which we will be solving the graph, right? So we notice the rate of reaction, which means R is equals to concentration of A, and it's not dependent upon the concentration of A, since I'm writing here that you can get an idea. This is A with power 0. Okay, maybe it's prominent. So first of all, look at the rate of reaction with the time. As you can see here, the rate of reaction is not dependent upon the time, it's only dependent upon this constant. So it's a straight line graph, right? Straight line graph only is parallel to the time axis, not dependent upon the time. If you see this one graph, okay, there's one more graph. Let's just discuss that graph. Then I'll be proceeding further to another one graph. It's something same like this. This is something like this. Here we represent time, while here we represent actually rate. Time is done, yeah. Then concentration, right? Rate versus concentration graph. Let's just erase that. I forgot it. Start. Let's draw it again. So this graph is something like this. Here we write time. Here we write concentration. I don't know, since I've not got any space, I'm writing something like this. And when you draw a graph, it's something like this, parallel to time axis. This is all not dependent upon the A naught. It is not dependent upon the concentration. So again we get a straight line graph. But we look at the zero order reaction here. Zero order, how it's we have visualized it or generalized it. So we know the formula that A naught is equals to A is equals to A naught minus B. A naught minus A T. Means we are familiar with it. Yes, this is the general formula of zero order of reaction. Other way of writing this formula is A is equals to minus Kt plus A naught, minus Kt plus A naught, minus Kt plus A naught. This is something like this. Let's move a little down. What happened? Fine. It is something like this. Y is equals to mx plus c. M represents slope here, x means x-axis plus c interruption, which means c is here, c. This is c. You can see here, this is c. Intercepting here, right? So you can see that the slope is negative and this is dependent upon the concentration of A. So it goes the negative slope, which is we can see there minus K is given here, so it goes the negative slope. So this is a graph of, as I said, that the rate of reaction is not dependent on the concentration of the rate of reaction, but reaction depends upon the concentration of it and decreases with the passage of time. Zero order reaction, same as concentration versus time graph. This concentration, remember here is discussing about this one concentration. Now straight line graph, then this graph. Now I would like to discuss about the product graph as well. So FE graph is same. Graph is remaining here. The half-life graph. So let's read it. Now I'm going to discuss some other graphs that are not given here. So first of all, half-life graph. Now I'm drawing half-life graph. For drawing half-life, let's write this equation. We know that the T 1 by 2 is equals to A naught divided by 2K. A naught divided by 2K. Is it so? Yeah, it's for 100% true. A naught by 2K. So here the time is directly proportional to concentration of A, which means that if we talk about the time and initial concentration of reactant, the time is given here, and we have represented here concentration of A naught, initial concentration of A naught. So it's directly dependent, as you can see here. So it goes a straight line graph. There's a straight line graph goes something like this. This shows us it is directly proportional. Right? So these things that we need to keep in mind. And the other graph that I would like to discuss here is, let's read it. This is half-life graph. Let's draw the graph again. We need to do some solutions as well for this purpose, for this graph, which is needed to be done. Okay, so we know that this graph is only capable for when A directly goes to product. This is only capable for this sort of equation. We know that at the time A naught at the time 0, A naught is 0. Initial concentration is of course 0 at the time 0. The reaction does not start, so it's 0. Right? But if the time t some concentration has been reduced from the initial concentration, you can agree, I can agree it. So it's something like this: A naught by right? And we know that the equation of written something like this: A naught by x. We know the other form of equation which we derived in the previous video, that's A naught by kt. Right? Let's compare the both formulas. A naught by kt, and then is equals to A naught by x minus. Okay. E naught cancels E naught, minus cancels minus. So here X is basically a concentration of product. This is product, this is product. And you can see that product is directly proportional to the concentration with the time. So if we draw this is product. So if we draw a graph of product versus this, here we have given the concentration of product, concentration B, product, B, product. And here we given the time, so they are directly proportional. Straight line graph goes something like this. So that is the graph.